Okay, welcome to the k-means clustering video. We're using the same data that we used for the hierarchical clustering. And we have here these 22 companies, the full 8 variables, and we've got them standardized already. So these have already been standardized, just calculated z-scores for the original data. If you want to see that, just go back to the hierarchical clustering video where we did that. So we're all set up to do k-means clustering. For the k-means clustering, we're going to do it with 4 clusters this time. In class, I did it with 3 clusters and with only 2 variables. I'm going to do the bigger version here just because it's a video. It's a recording. You can pause and rewind and stuff. And I don't have to worry about you keeping up with me as I go and trying to do everything I'm doing, because like I say, if you're trying to follow along on Excel, you can always pause and stuff. So we're going to need 4 centroids to start. We start with 4 guesses. Now I'm just going to use my 4 initial centroids, just the first 4 points, because why not? So centroid A is going to be Arizona, centroid B is going to be Boston, and centroid C is going to be Central. And finally, centroid D is going to be Commonwealth. Okay, so there we go. Now, you'll see here that for each centroid, now I have all of these, and I'm going to set up some formulas. I just want the same number all the way down. You could just copy and paste the numbers all the way down, but it's actually going to work a little bit nicer for later if we make these a cell reference. So I'm just going to do that all the way across and all the way down. So you can see it's the same centroid every time. Whoops. I'm just trying to, I want to paste my formatting. Here's what I want to do, actually. I'm just trying to fix the formatting. Just want it to look a little bit nice. All right, and so same thing here. We're just going to use a cell reference. This is the cell above it. Right, and then we're going to go down and we're going to go over. So the same centroid is just getting repeated all those times. I can do the same thing over here. And for centroid D, same thing over here. Okay, so this is nice because when I copy and paste everything, which I'm going to do later, I'm going to copy and paste everything, this cell will always refer to the cell above it. So when the cell above it is not this fixed number, but some different number in the next iteration, and then the cell references will already be there, already automatically having been updated. So now we need to calculate distances. So the idea is we have these 4 centroids, and we're going to find the distance from every point to each of these 4 centroids so that we can tell which centroid is it closest to. So for point A, Arizona here, for centroid A, the distance, right, we're going to do the square root of the sum xym2 of this and that. And because I'm going to be copying and pasting that over to B and C and D and so on, I just want to make sure the blue one doesn't move left and right. I want it to go up and down, but not left and right. So I want to just fix that column B and column I there. Oh, I typed it wrong. XMY, not XYM. There we go. And so now these distances should go down here. And then I can do the same thing over. Actually, I'll just copy the whole column, right? Copy this column here and here and here, and you can see the zeros are where we expect them to be because like the third point was centroid C. So the distance between the third point and centroid C is 0 because it is centroid C. So then finally over here, for each of these points now, we're going to figure out which centroid is it actually closest to. So we're going to have a minimum distance, and that's just going to be the minimum of the 4 distances we have. So this distance, this distance, this distance, and over here, that distance. right? So these are the four distances from Arizona to each of the four centroids. We're taking the minimum. Of course, that's 0. Arizona is distance 0 from itself. And then what cluster do we assign it to, right? So if the closest centroid is centroid A, then we're going to assign this point to cluster A. So this is a little if statement. If this value that we found, the minimum distance, is the distance to centroid A, we're going to assign it to cluster A. Otherwise, if this distance is equal to the distance to centroid B, then we're going to assign it to centroid B, cluster B. Otherwise, if this distance is equal to the distance to centroid C, then we're going to assign it to centroid C. Otherwise, it must belong to group D. What else could it be? Process of elimination. Okay, so of course the first one goes to cluster A, and we're expecting, because we picked A, B, C, D to be the first 4 points, we're expecting to see the first 4 all being zeros and the clusters being A, B, C, D. But after that, we don't know what to expect. After that, it could be anything. So when we zip this down, we see what we expect, right? Zeros here, and then A, B, C, D. That's because those points are the centroids to begin with. And then these ones are different. Okay, so what we've got now is we've got this whole thing all done. And I'm actually going to insert a little column on the left here. And I'm going to write iteration. And I'm going to start with a bunch of zeros. And the reason is because I'm going to have iteration 0, and then I'm going to have iteration 1, and iteration 2, and iteration 3, and so on. And we're going to iterate. We're going to copy this whole thing down over and over and over again. So what we've done is we've calculated the distance from every point to each of the 4 starting centroids. And then we've assigned every point to a cluster based on which centroid it was closest to. That's here. These are the clusters we've assigned. So now we're going to take all this and we are going to copy and paste it down again. And of course, it's exactly the same. But what we're going to do now is we're going to change this formula. So the iteration should be, it shouldn't be 0, it should be 1. The easiest way to do this is just to make this equal to this plus 1. And if I copy that all the way down, then I've got a bunch of 1s. But more importantly, not only do I have a bunch of 1s, but when I copy again, I'm going to have 2s, and then 3s, and then 4s, and so on. But that's just a little keeping track of things thing. The really important job that we have to do now is, now that we've assigned every point to a cluster, and we have 4 clusters, we want to calculate the 4 new centroids for those 4 clusters. So we're going to do that. So we've got here the centroids, and this, remember, all these other rows are just cell references to the previous row. But this top row for this centroid, that's actually just like hard-coded in right now. We're going to want that to be calculated. And so what we're going to want to do is we're going to want to calculate the average. Now we're doing the fixed, right? Then we have ROR, then we have cost, we have all these different variables. So we're going to do the average of all of the actual data, right? All of these fixed, but it's if, right? So we're going to do an average if. So, oh yeah, right. Average if is different from average ifs. If you average ifs, you put the thing that you're averaging first. But for average if, it goes at the end. Kind of weird. Anyway, average if, the range, we want to look over here at all the clusters assigned, and we only want to use this if it's an A. And then the thing we want to average is these actual fixed values here, right? We're going to average this variable if it was assigned to cluster A. If it wasn't assigned to cluster A, we're not going to include it. So it looks like this. Now, this red one we want to move over as we move this over, right? But the blue one should not move because the blue one is referring to this cluster column. And if that moves over, it just goes into blank territory over there. So we don't want that to move over. So we're going to make that static. Moving down is fine, right? We're not copying and pasting this down rows, but when we copy the next iteration, it's got to go down. So these have to be able to go down. Okay, but we don't want the blue one moving over. So this one is going to work all the way across to fuel cost here. And then we want the same thing over here, except instead of an A, we want a B. So if I copy and paste this, then my red reference is in the wrong spot. So I don't really like that. I'm not going to do that. What I'm going to do is I'm actually just going to go into here. I'm going to grab the text, copy and paste it. And now it's in the right spot. And so now I just need to change the A to a B. Oops. Change the A to a B. And now that can just zip over here, copy and paste that across. Now we have a new centroid. And then same thing, all this text is going to go here for centroid C and here for centroid D. And then for C, we're going to change the A to a C. And then for here, we're going to change the A to a D. And then we're going to zip that over. And we're going to zip that one over. And so what we've done now is we've recalculated 4 new centroids. And these new centroids are actually in the middle of their clusters, right? We assigned points to 4 different clusters. And each of those clusters has a middle, which is the centroid. And these are those 4 centroids. But now what happens is now that we've assigned, now that we've moved the centroids, all the other formulas kick in and they measure the distance from each of our original 22 points to each of those 4 new centroids. And they assign them a new cluster. And these new clusters might not be the same as the old clusters, right? It is still ABCD. Let's see, ABCD, BCBACD, ABCD, BCBACD. So the first bits are the same. And then ABD, ABA, ABD, ABA, BAAD, BB, BAAD, BB. That's interesting. These clusters don't seem to have changed. It's actually totally possible that our original choices were quite good just by chance. And if that happened, right, I just chose them because those were the first 4. It was basically random, right? They're sorted alphabetically by company name. So if we're already done, which might happen, then that's just luck, right? Just lucky we could be done already. But what we're going to do is we're going to copy and paste this down and we're going to get another iteration. And we can see that what happens here is that this is iteration 2 and the centroids should update and so on. And then iteration 3, I'm going to copy and paste a bunch down because even if we already have what we want by iteration 2, that's okay. That might not always happen, right? Because we're going to be randomly selecting points sometimes. And so we might have just gotten lucky this time. All right, so I'm just copying down all these iterations. We're going to have 10 iterations. That will be plenty, I think. I think that this should converge within 10 iterations every time we do it. Okay, so the way to tell if it's actually done is if the centroid if none of the centroids change from one iteration to the next. So obviously from iteration 0 to iteration 1, they changed. But then from iteration 1 to iteration 2, this doesn't change, this didn't change, this didn't change, and this didn't. Okay, the centroids didn't change. So I think we actually finished immediately. We just got lucky. The first 4 centroids were probably reasonably well chosen, and then the clusters we got out of them were already good clusters. So that was lucky. That doesn't usually happen. Either that or I made a mistake and you're gonna get to see me troubleshoot the mistake. But I think this is probably good. So what we're gonna do is we're gonna see, and the way we're gonna see is we're gonna look at the a measure of the variability within each cluster. All right, and the measure of variability within each cluster we're gonna do is simply just adding up those the distances from each point to the centroid within that cluster. And we're gonna do that for all the clusters. Right, so we're just gonna do here, we're gonna have iteration, and then we're gonna have 0, 1, and so on to 10, with 10 iterations. And then we're gonna have total cluster distance. Right, so this is just adding up all the distances from each point to its centroid. And so what we're gonna, and that would be the minimum distance column here, right? So all we're gonna do then is we're gonna do the sum if, and then we're gonna sum this whole column. Oh, sorry, no. The range needs the criteria. So the range over here, we're gonna look over here in column A, and if column A is equal to the iteration that I want, so in this case, iteration 0, then I should sum column AU. Right, and then this just zips down. And yeah, that is what happened, right? So we can see that after iteration 1, iteration 2 was the same. It stopped changing. We settled into a nice pattern right away. A little bit of luck there, but that's fine. So what I'm going to do now is, this is it, right? This is the algorithm. If you have to do a question where you're given the initial centroids, this is what you do, right? We're done. The last thing I'm going to show you, though, is just randomizing those centroids. So what I want to do to randomize the centroids is I want to have a reference number for each. And so the reference number I need, I'm just going to generate a random number, random between 1 and 22. Right, so 9. All right. And I actually don't have a reference number column over here, but that's okay. I'm just going to grab these to make a little table myself. Actually, let's just grab this whole table. All right, we'll grab this whole table, we'll add reference numbers to it. Just move that over here, just so we can select some random points from it. We'll put that over there. That should be enough space. And I'm just going to add reference numbers here. 1, 2. Put that down. Okay, so here I have. Oh, by adding reference, I don't have quite enough room. I need one more column, I think. All right. So once I have the reference number, I just want to do a little VLOOKUP here. And so this is going to be just a vertical lookup. I'm looking up the reference number here on this table. And oops, I'm looking up this reference number on this table. And I'm looking in column 2. Oh, and I should put false because I want only exact matches, just in case there's a problem. It shouldn't be a problem because this one's sorted by reference number, so it should not be an issue. But just do that just in case. Anyway, I'm going to take this. I'm copying the text only, not the cell, because I don't want to deal with things sliding around on me. And I'm just going to change the 2 to a 3, the 3 to a 4, change it to a 5. Oops. I changed the comma to a 5. Not what I meant to do. Oops. I did that 5 already. 6, 7, 8, 9, 10. Okay, so there we go. If the reference number is 2, we're selecting Boston, and then this should look like Boston here, which it does. That's good. So now I need I need more random references, right? So random between, if I just do the same thing, right? Oh, I should have made this reference static before I went and made all those changes. That's slightly annoying. Didn't think ahead. I knew I was going to be copying and pasting it, and I just didn't think ahead. All right. No, not the blue one. Not the blue one. The red one's getting static. Should have done this before I copied it over 8 times. Oh well. All right. Zip that down, and there we go. 4 randomly selected points. Okay, but we have a slight issue where those points might end up being the same points sometimes. I'm going to show you how we can fix that with a little bit of math in a sec, but let's just go over here and put these in, right? So centroid A is going to be just this first one, right? BC2, and then if I zip that over, that gets me centroid A, right? And then centroid B is going to be just the second one over here. I'm going to click on this one there, and then I'm just going to zip that across. And then centroid C is going to be the third one. And I'm going to zip that across. And centroid D is going to be the fourth one. And I'm going to zip that across. Okay, so we should still see 4 zeros, because there are 4 randomly chosen centroids. They're just going to be in different spots each time we do it. So we can see that as we do this with the random selections, we get different, like this one doesn't converge as quickly. Right, this one takes until step 3 before we've got the final clusters. And when we see this, we can see there's lots of different possible things that can happen. Right? Sometimes it converges really quick, sometimes it takes longer. Generally speaking, the ones with a lower total cluster distance are better. So, and also the ones that we see most often are also in a certain sense better, right? They're maybe a little bit more natural. Right? But if we see this is the minimal, this is the total cluster distance we get, right? We may want to say, oh, that's the best one yet. We haven't seen one below 40, but now we just did, right? Maybe these are really good clusters in the end. So after iteration 3, we get these clusters, right? And they stop changing after a certain point, but we can see what those clusters are, right? Maybe these are really good clusters. We can compare them to what we got when we did the average clusters, right? So Arizona and Central and Florida and Idaho and Kentucky and Nevada were all in the same cluster. And then if we look over here, we have let me just grab those names so I can see them. I just need to see what those names are. Oh, but now I re-randomize. So by re-randomizing, I get other stuff happening. And when we re-randomize, we can see sometimes we have problems. Why are we having problems? It's because we get the same number 3 times. If you get repeated numbers, it's not good. The thing breaks. You can't start with 2 of the same centroid. All right, so I'm just gonna re-randomize until I get a nice. Okay, so here's a nice small one. That's around 40. All right, so if I just go down here, right, I can compare these to what we got on the other sheet, right? So Arizona and Central and Florida and Oklahoma and Southern are all in a cluster here. Using the other method, we got that Arizona and Central and Florida, but also Kentucky was in that group. And over here, Kentucky's not in that group. Kentucky's got a different cluster. And over here, Oklahoma and Southern and Texas. And here we have Oklahoma and Southern and Texas, right? So the cluster we got, the first cluster here, is very similar to the cluster we got using the hierarchical clustering, but not exactly the same, right? There's a little difference here where the hierarchical clustering thinks that, where was the difference? Kentucky? Yeah, it thinks that Kentucky should be in that cluster, but the k-means clustering does not. It disagrees. It thinks that Kentucky should belong to a different cluster. So that's, that's fine. That's what we expect when we use different methods. We get different results. Okay, last thing I'm going to show you then is how do we fix this problem where we occasionally randomize ourselves into the same number. So here's the deal. If you have like a programming language and you're doing this in the programming language, it can randomly select 4 distinct points pretty easily. Excel, I don't think has that ability. It might, like, I don't know every single function Excel has. It has thousands, so I could be wrong, but I've never seen that ability in Excel. So what I'm going to do is I'm just going to do a little bit of a hack. So I'm going to randomly generate these new numbers here. Give myself a bit of space. So now the way this is going to work for the first, okay, so for the first one, I just randomly generate a company between 1 and 22. Now there's only 21 companies left. So I'm going to randomly generate a company between 1 and 21. But the way this works is I want the numbering to go not 1 to 21, but I want it to go like, for instance, if the first company selected was company 5, I want my numbering system now to be 1, 2, 3, 4, skip 5. So 1, 2, 3, 4, 6, 7, 8, 9, right? So the way this is going to work is if this number is less than that number, then that number is the correct numbering. Otherwise, I have to add 1 to it. Okay, so now these two numbers will both be between 1 and 22, but they will never be equal. And then here what I have to do is I'm going to have to what do I do here? I do if this number is less than the minimum of these two, then I can just use it. Otherwise, it must be bigger than the lower one. If it's bigger than the lower one, I need to add 1 to it. At least 1, because it might also be bigger than the higher. So, but I need to add at least 1 to it. So then I'm going to say if this number plus 1 is lower than the larger of those two numbers, I can just use that number plus 1. Otherwise, I have to add a second number to it, add 2 to it. Okay, so I've got now 3 numbers. Oh, and this should not be between 1 and 22. This should be between 1 and 20. Because there's only 20 companies left to choose from. All right, so you can see it's getting complicated. The fourth one is going to be, even more complicated. It's going to be a little bit annoying to how complicated it is, but let's try it. So if this number is less than the minimum of all of these, then I can just use it. On the other hand, if how do I do this now? I'm trying to think. It's actually a little bit tricky here because we want to know if it's less than the second value. I'm trying to remember the formula for the second smallest value. Let me just, I have to look that up. I've forgotten the name of it. Yeah, there it is. The kth smallest value. Right. Okay. So the function is small. All right. So if it's less than the minimum, the smallest, then I use the number. Otherwise, if that number plus 1 is less than the second smallest, so how do I do the second smallest? I use small these two, that'll give me the second smallest. Then I can just use this number plus 1. Otherwise, I have to do either plus 2 or plus 3. So then if this number is less than the maximum, the third smallest, the maximum of these, then I'm going to do this number plus 2. Otherwise, I do this number plus 3. And I close up all my brackets. And this should be ran between 1 and 19. Okay, so now all of these should always be between 1 and 22, and they should all be distinct. So I should never, and if I re-randomize a bunch of times, I should never run to that divide by 0 error. It should always work. Uh-oh, I saw divide by 0 error. Maybe my code was not correct. Let's try to troubleshoot. We need to randomize ourselves. Okay, so here. Okay, this one ended up being the same as that. That shouldn't have been able to happen. So what happened? If this number was smaller than the minimum, it was not. Then I was supposed to return this, 13. But it wasn't smaller than the minimum, so I should go here. So now if this number plus 1, so if 14 is smaller than the second largest, it's not. Then I return 14. Otherwise, if, oh, whoops, plus 2. That's supposed to be plus 2, because I'm adding at least 2 at this point. Okay, there, now it should work. Pretty confident. I'm gonna hit this button a bunch. I'm just hitting delete to re-randomize. So if I re-randomize this a bunch of times, I'm never getting those divide by 0 errors. I can randomize a lot of times, and yeah, it always seems to work. So I'm never getting repeated values. So that's good, right? And so then what I could do is I could, each time I randomize, I get a new solution, but I could try to see, like, are any of these solutions coming out more than others, right? A solution that comes up over and over is a really natural solution, right? This is a solution that may indicate that those clusters are more natural than some of the other clusters you might make. Also, clusters where the total cluster distance is small are good choices too, right? So using those two criteria, right, does the answer come up a bunch, and is the total cluster distance small? I can try to find myself some real nice natural clusters, which hopefully will help me in my analysis. Okay, so there we go. That's it, right? That whole randomization part, maybe you don't need that. I don't know. It's up to you how much effort you want to put into making sure you don't get duplicates here, right? If you're just doing it by hand anyway, then you can just say, oh, we got a duplicate and it broke. That's fine. We'll ignore that. Re-randomize, get the next one, right? It's not a big deal. But if you do put the effort in, that's the one way you could do it. Honestly, there might be a method that just gets you the distinct random numbers. I just don't know what it is. And there may not be. It may not exist. I don't know. Anyway, that's it for the video. All right, that's k-means clustering. And we are all done the topic for today. So I'll see you in the next video.